Geometry, a real power tool. Unit created by Tracy Zano. Tools are as useful as you make them, and the more you practice using them, the more useful they are. What is a tool? Why do we use models? To what extent can we apply two-dimensional geometry to a three-dimensional world? What tools are essential to building and architecture? How do we know that a design is good? How close is close enough? Students will design and build a storage shed or other piece of furniture. Students will be expected to work collaboratively to create possible designs and eventually build them. Teams will put forth proposals with budgets. We will vote as a class for which one we will build together. We will work with local experts to assemble the pieces and build a final product. Students are expected to use their knowledge of geometry to create a plan including scale drawings, careful measurement, surface area and volume, and a budget. By the end of this unit, students will know formulas for finding perimeter, area, surface area, and volume. Vocabulary including perimeter, area, surface area, volume, circumference, polygon, regular polygons, similar figures, congruent, units of measurement, etc. And that similar ratios for x for the length, 4x for the area, and 9x for the volume. By the end of this unit, students will understand that tools need to be carefully selected for appropriateness and application. Tools can be physical objects, nails, hammers, wood, calculators, or metal constructs, mind maps, organization, problem-solving strategies, formulas, and to plan before you act that you can look up specifics, but you have to decide what tool to apply, and that 2D geometry is often a useful model. At the end of this unit, students will also be able to measure accurately to the nearest 1/16 of an inch or nearest millimeter, calculate area, perimeter, circumference, surface area, and volume of individual and composite shapes given the formulas, explain why the ratios go from x to 4x to 9x, create 2D scale drawings from a variety of perspectives, front view, side view, etc., sketch basic 3D shapes like cubes and rectangular prisms using isometric graph paper, draw 3D scale plans using technology such as Google SketchUp, convert within the metric system and within the English system, and illustrate in their plans and final product the importance of careful measurements in building. During this unit, the following Vermont standards and grade expectations will be met. In this project, you will be working in teams of 3 to design a shed. Each team will present their design plan to the class and local experts for evaluation. We will be voting on the design we like best so we can build it. You will be given a list of supplies that have already been donated for our use. You will have $100 to spend on additional supplies. Before we complete the shed, we must decide what to do with it. We can donate it to a local organization or charity, or auction it off as a fundraiser for the school, or any other idea you might come up with. We will decide together what the function and use of our shed will be before designing. Your final submission must include a series of 2D to scale drawings from different perspectives, a 3D model created in Google SketchUp, a budget limited to $100, and a detailed written explanation of your plan and why you chose the design you did. Your final submission will be reviewed by the class, the local experts, and Ms. Zano. Your final grade for the project will be an average of these 3 evaluations. The submission with the highest average will be the design that we make together. Directed by Darcy Perry, copyright 2010.